All right, so now we're going to take a look at converting between fractions and decimals. Since we've already talked about what a decimal is and we talked about what fractions are and the relationship that we have between both of them. They're both rational numbers, they're just different ways to express the same value. With fractions, we had two numbers dividing in order to express a value. With decimals, we have a number written out in such a way that each place value has a digit in it to help us understand what the value is as a whole. In fact, we call it decimals because everything is based off of powers of 10, deci meaning 10. Just like what you saw with your whole numbers when you first looked at place values. There's no different. In fact, that's why they call it a decimal system, because everything is based off of how many do you have in each placeholder going from 0 to 9. In other words, 10 digits. Once you get one extra, you move up to the next level, and so on and so forth. But anyway, what we're trying to do here is look at how do you convert between fractions and decimals. So very simply, we're going to look at how to convert from a fraction to a decimal first. And then we'll look at going from a decimal to a fraction. So going from a fraction to a decimal is actually quite easy. The first thing you want to do is remember that a fraction is just a division problem. The only difference is we're going to actually divide it. So let's take a common fraction that people like to convert to a decimal. For instance, 3/4. Now, how would I change 3/4 to a decimal? Well, I would do exactly what 3/4 says to do. It says do 3 divided by 4. So guess what? We're going to do 3 divided by 4. So if we were to do that, we would say, well, what is 3 divided by 4? And the first thing you would say is 4 can't go into 3, Mr. Stevens. So how do we do this? Well, 4 goes into 3 0 times. And 0 times 4, of course, would be 0. We would subtract that and we get a 3. And then that would be our remainder. Well, let's say we did this so that we had no remainder. How would you do it then? Well, we can add a decimal at the end of the 3 and do the same in our quotient here. And then add a 0 at the end. Because if we keep adding zeros, what we're saying is that there is nothing going into this placeholder. So the value as a whole stays the same. However, we have changed the way 3 looks. Now it says 3.0. Has the same value, but looks different. And now we can divide with it because we have something to bring down. We can bring down a 0. So how many times does 4 go into 30? That we can do. 4 goes into 30 7 times. 7 times 4 is 28. We subtract and we get a 2. So we have a remainder of 2. Let's keep going until we have no remainder though, or we see a pattern. So we can add another 0 because that still has a value of 3. It just looks different. If we have a 0, we can now bring down. So how many times does 4 go into 20? Well, it goes in 5 times. And 5 times 4 is 20. And when we subtract that, we finally get that remainder of 0. So 3/4 will be the exact same as 0.75. All right, so that's converting from a fraction to a decimal. And now it's fairly simple. We just divided it exactly as we see it. Let's look at one more example of changing a fraction to a decimal by just dividing the numbers. So what we're going to look at is 2 knives. Okay, 2 knives. Well, let's see what happens with 2 knives. So we want to know what is 2 divided by 9. Well, let's see. Well, how many times does 9 go into 2? Of course, you know that's 0. 0 times 9 will give us 0. We subtract and we get a 2. And we're done because our remainder is 2. No, we know now that we can add a decimal at the end and add a 0 and bring down our next 0. So 9 goes into 20 how many times? Well, it goes in twice. But don't forget that decimal in the quotient. Goes in twice. 2 times 9 would then be 18. We subtract and we get a remainder of 2 again. Okay, cool. So we're done. We got a remainder of 2. Now, we can add another 0. So we're looking at 20. Now, how many times is 9 going to 20? That's right, it goes in twice. Multiply that, we get 18. We subtract, we get 2. So we can stop. Well, now we have a 2 again. So we can keep going. 0 remainder. Let's add 0 again. We get 20. 9 goes into 22 times. 2 times 8. Now 2 times 9 is 18. We subtract, and we get a remainder of 2 again. And what's going on? Why is just it's the same thing? Oh, I said until the remainder 0, we see a pattern. You probably saw the pattern at the second one, right? I hope you did. You didn't take as long as Mr. Stevens did you? I don't think you did. Well, at this point here, once we saw that we were going to continue to get 20 down here, or get a remainder of 2 every time, then that means that we could have stopped. Because that means that this decimal is going to repeat. So, what we can do then, a shorter way of writing this, is by saying that 2 ninths is equal to 2 repeating. You can put just a line over the number that repeats. So it's more than one number that repeats, you put the line over every part of it that repeats. So I can write this as 0.222, and I can have the line go over all of this. Or I could just say, hey, it equals 0.2 and put a line just over there. That means the 2 is going to keep repeating over and over again. This is a cool thing, because when you see repetition, it's generally over a factor of 9. So I wanted to make sure I showed you that example as well, because sometimes it doesn't terminate. Terminate means end. That's why the Terminator came back in time to kill the mom and kid and stuff, because he wanted their lives to end so they wouldn't be a threat. Termination, ending. But sometimes, instead of our decimals terminating, they repeat. And when they repeat like this, we need to be able to tell when it repeats. And when they do repeat, it's generally because, well, actually, I could actually prove to you that it's always because it's over a 9 or 99 or 999 or over some list of 9s. So anyway, that's how you convert from a fraction to a decimal. Let's look at the other direction, going from a decimal to a fraction. All right. Well, we'll start off with this number. Well, how do you read that number? Oh, well, that's the tenths place, that's the hundredths place, that's the thousandths place. Okay, good. I'm glad you know that. So you would read this as 107 thousandths. Well, why don't you write it like that? Okay, Mr. Stevens, 107 thousandths. Wait a minute, that's a fraction. Is that all? Yeah, that's all. The only extra thing you may have to do at times is simplify your fraction. For example, let's see what 0.75 is as a fraction. Well, we actually saw this earlier, so you might know the answer. But let's just see what happens. How would you read this? Well, I know this is the tenths, and this is the hundredths place. So this would be 75 hundredths. Okay, good. Well, can you simplify it? Yeah, I can divide both of those by the number 25. And if you didn't know that, you could have started at 5 and did 5 again. That would have been completely fine. That would have been completely all right. So 75 divided by 25 will give us 3. And 100 divided by 25 will give us 4, which is what we saw earlier. 0.75 should be 3/4. Huh, that's pretty simple. Just like most things are. Keep things simple. Don't try to complicate anything. It may not be easy, but you can still keep it simple. That's something to remember for life. So converting decimals to fractions, write it exactly as it says. This said 75 hundredths, this said 107 thousandths, and then just simplify. But what about one of those repeating decimals you talked about? Okay, well, let's look at one of those repeating decimals I talked about. Okay, let's say we had 0.6 repeating. Okay, remember how I said that each one of those is just going to be over 9 or 99 or 999? just over a certain number of nines. Well, how do you figure out which one it is? Is it 999, 999, 9,999,999? I don't know. Actually, I do. The hint is how many digits are repeating? Well, there's only one in this case. So let's write down the number. 6, it is what it's repeating. And let's put it over 9 because there's only one digit. So if this was, say, 23 repeated, this would be 23 over 99 because there are 2 digits repeated. So this would end up being our answer. And that's how you convert repeating decimals into fractions. But what if they reduce? They reduce them. For example, 6/9 up here, we can divide both of these numbers by 3, and we'll end up with 2/3. That's a common fraction that's used, 2/3. So it's really just 0.6 repeating, or it's also 6/9. Okay. So what about those times where we see something like this? 1 with just the 6 repeating. So all the stuff in the front didn't repeat. Mr. Stevens, what do we do now? Well, we can separate these two things, can't we? I believe we can. So we have a 1/10 okay. And what do we have here? We have a 6 repeating. And you would put that over 9. Well, that's an issue though, isn't it, Mr. Stevens? Because this start off over here, and this number is definitely less than that. You're right, it is. Then what should we do? This was in the hundreds place to start off, right? Yeah, it was. So in this case, we would want to then look at it being over 90. Because we still only have one digit repeating, so we have it over 9. But because we moved over an extra decimal or an extra place value, we have to add another 0 here. Because honestly, when you're moving over in the decimals, you're moving over to the right, you're just dividing by 10, right? So if we were to divide 6/9 by 10, this would just end up being 6 over 90. Let's show that so that you can better see exactly what I'm saying. So as we move over, for instance, if this was 1/10 here, that would be the same thing as a dime, right? And as we move over this way, it would be 1/100th. That would be the same thing as a penny. Well, if you take a dime, you split it 10 ways, it's a penny, right? Okay, well, let's look at it mathematically. So mathematically speaking, what will we do here? Well, we would have taken 6/9 and divided by 10. And we remember when we were dividing fractions, we're really looking at 6/9 times 1 over 10. And if we multiply that, we will get 6 over 90. All right, so going back to where we started, if you only have a latter part repeating, write the first part as a fraction. So in this case, we have 1/10. And we're going to add to it the part that repeats. So how many digits do we have repeating? 1. So we have 6 over 9. We add another 0 at the end here because we moved over one extra decimal place to begin. So now we can add these two numbers together. Well, they're not the same denominator, so I have to do more work. That's fine. You've already had practice adding and subtracting fractions. So we know that in order to do this, we must have the same denominator. And looking at this, both of these could become 90. How would you make this guy into 90? That's right, you multiply by 9. Same thing up here. So we will really get 9 over 90 plus 6 over 90, which would give us 15 over 90. And you can divide both of these guys by 15, and you will end up with 1 1/6. And that's how you would convert from a repeating decimal to a fraction. So, to go from a fraction to a decimal, we divide it just as we see it. You see 2 7s, you would do 2 divided by 7, and keep going until you either saw a pattern begin with the remainders or your remainder is 0. To convert from a decimal to a fraction, write it exactly as it says and then simplify the fraction. So if it said 0.23, you would change that to 23 hundredths because it would be hundredths place. If you see a repeating decimal, write down the number that's the digits that are repeating over that many nines. So if we saw 0.232323, we would have 23/99 because we have 2 digits repeating, so 2 nines. And in cases where you have only a latter part repeating, write the first part out as a fraction and add to it the latter part as a fraction. Remembering how to do that with repeating decimals, write the digits that are repeating over 9, and then just add zeros for every place value that you moved over. And then add the two together and simplify, and you're done. I will see you soon.